Hello students, welcome to Wandukam. In this video, we will discuss about the electrochemistry of the first module. So, this electrochemistry is the branch of chemistry that deals with the relationship between electrical energy and chemical changes that take place in reaction. Which reaction? In redox reactions. That is how the chemical energy that produced in a redox reaction can be converted into electrical energy, or how the electrical energy can be used to bring about a redox reaction which is non-spontaneous. Here, when there is change from the chemical energy to electrical energy, then the redox reactions are spontaneous. Whereas when the electrical energy is converted into chemical energy, then the reaction involved, or the redox reaction, is non-spontaneous. That means the production of electrical energy or the electricity that is based on the spontaneous redox reaction gives rise to the cells known as electrochemical cell or galvanic cells or your voltaic cells. We can also say in these cells chemical energy is converted into electrical energy, and most common example of such type of cells or the galvanic cell is Daniell cell, where two half cells, zinc and copper, are used. Let us discuss in detail of this Daniell cell. This is the Daniell cell, which consists of a zinc electrode dipped in zinc sulfate solution and a copper electrode dipped in copper sulfate solution. These two half cells are connected internally by a salt bridge containing potassium chloride or ammonium nitrate with porous plug on either sides, which helps in the movement of ions between the two half cells. Again, these two half cells are connected externally by wires through a voltmeter. In this cell, spontaneous redox reaction takes place. In the zinc electrode, oxidation takes place by the liberation of electrons. So, this is the negative electrode or the anode. Similarly, reduction takes place in the copper electrode by the acceptance of the electrons from the external circuit. So, it becomes positive electrode or the cathode. Let us see the cell reaction. At the anode, oxidation reaction takes place where metallic zinc is oxidized to ionic zinc by liberating two electrons, and these two electrons are used up by the copper at the cathode. So, copper ions are reduced to metallic copper. So, overall cell reaction is this, and by adding the anodic reaction and cathodic reaction, we will get the overall cell reaction. Let us see the cell notation for the Daniell cell. This is the zinc half cell where zinc and zinc ion, and this is the copper half cell where copper ions and the copper electrode. This is the positive electrode or the cathode, and the zinc electrode is the anode or the negative electrode, and this is the phase boundary between the solid and aqueous phase, and this is the notation for salt bridge, and you can see the direction of electron flow. Anode is always written on the left hand side and cathode is on the right hand side of the cell notation. So, as long as there is flow of electron from anode to cathode, we would get electrical energy from the cell, and there will be cell reaction in both the electrode or the half cells, and potential can be measured from the voltmeter, isn't it? When the reaction attains the equilibrium, both these half cells, the reaction whatever is going on, it becomes equilibrium, then there won't be any flow of flow of electron stops, no work can be done by the cell, and the cell potential or the EMF of the cell becomes 0. So we can also measure the EMF of this Daniell cell. At an appropriate condition, we call it as your standard condition, when the zinc sulfate or the zinc ion concentration and copper sulfate or copper ion concentration is 1 molar, and temperature is temperature I am writing in short, 25 degrees centigrade, pressure is 1 atmospheric pressure, then this Daniell cell zinc copper electrode, the cell EMF is 1.1 volt. I will tell you how we are going to determine this. So the single electrode potential or the reduction potential of zinc electrode or the standard potential of standard reduction potential of zinc is equal to 0.76, sorry it is not visible, volt, whereas that of this standard reduction potential of copper electrode is 34 volt. Then the standard cell potential, standard, why I am using this word standard, because this is the standard condition. So standard reduction potential of cathode minus standard reduction potential of anode. Here this is the anode, this is the cathode. So we can put minus 0.76. So we will get 1.1 volt. This is the ENODE cell or the potential of Daniell cell at standard condition. Now I would like to tell you that the single electrode potential, suppose in case of zinc and copper whatever I have written, the single electrode potential can be always represented as reduction potential or standard reduction potential. Based on the standard reduction potential of different metal ions, one series is there, electrochemical series. From that series we can find out the reduction potential of any electrodes, any types of electrodes, and from the electrodes we can find out the standard cell potential. Just have a look into this electrochemical series where these elements are arranged as per their standard reduction potential. Lithium is the element with less standard reduction potential and more reactive, whereas gold and platinum are less reactive and known as noble metals. Did you mark one thing in the cell notation, that I have put the zinc electrode or the zinc half cell in the left hand side is it, and copper in the right hand side of the cell notation. Here in the left hand side, in the zinc electrode, oxidation reaction takes place, and in the copper electrode reduction reaction takes place, isn't it? So why not the same is happening in the other way around? Copper would be your anode and oxidation takes place in copper electrode, and zinc would be your cathode and reduction reaction takes place in case of this zinc electrode. If you want to know the reason for taking zinc electrode as anode and not the copper as anode, you please watch my next video for the explanation. So in my next video you would find more about standard reduction potential, cell EMF or cell potential, free energy change, and its relationship between cell potential. You can also watch out my videos with explanation in Hindi. So keep watching, keep learning. Thank you.